Today's class we'll see gradation of properties. Now these properties vary in period and group. 7 properties. The first property is atomic size, which is also called as atomic radius. Second one is ionization energy, which is also called as ionization potential. Third one is electronegativity. Fourth is electropositivity. Fifth one is metallic characteristic. Sixth one is non-metallic characteristic. And seventh one is valency. Now, when you discuss these properties in period and group, one thing you should remember is in period, we should move from left to right. In period, we should always move from left to right because the design is like that. See, lithium number is 3, beryllium number is 4, boron is 5, carbon 6, nitrogen 7, oxygen 8, fluorine is 9 and neon is 10. So, you're moving like this. So, you should also discuss in the same manner. When you speak about group C, from top to bottom, see, hydrogen number is 1, lithium number is 3, sodium number is 11, potassium will be 19. So, it is same from top to bottom also atomic size is increasing. Sorry, atomic number is increasing. Okay, so it's arranged like that. So, same manner we have to read. Now, there's one more condition. If you are speaking in period, you should be in the same period. You should not intermix up with other period. If you are speaking about group also, you have to stay in the same group. You should not intermix up. You didn't understand, I think so. Let me tell you. If you are speaking about one period, so for example, I want to speak in periods. What is happening to these properties in periods? Then what shall I do? I should select any period of my choice, and that should be the only period which I should remain in. So I am going to remain in second period. My favorite one is second period, so I am going to remain in second period. Suppose you want to discuss and you want to pick up third period, happily you can pick up, but you have to remain in the same period. Okay. Suppose you want to discuss in groups, so I'll select first day group. My favorite is first day. I'll be speaking about hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. If you want to speak about second day, your choice is second day. Happily you can take second day. Starting with beryllium, magnesium, calcium, strontium, barium and radium. It is your choice. But you should not intermix up periods and two periods and two groups. Right now, properties. So my first property is atomic size. This can be also called as atomic radius. Means atoms radius. It means atoms radius. That's all. So its unit is angstrom, and it is represented like this. Angstrom is represented with a, right, 1 angstrom is equal to 10 to the power of minus 8 centimeter it is, or 10 to the power of minus 10 meter. Right, now the topic rises in period as we move from, so I am speaking of period, in period as we move from left to right. Atomic size, what happens if you ask students what happens to the atomic size, they will refer like this. So second period, lithium number is 3, beryllium is 4, boron 5, 6, 7, 8, 9, 10. So simply they will say that atomic size is increasing, sir. Why? Because they are referring the atomic number, but the answer is wrong. In period as we move from left to right, okay, atomic size decreases. In group as we move from top to bottom, atomic size increases. Easy to remember. See, in group what is happening? Groups, this is n is equal to 1. This is n is equal to 2. That is, this number is for period. This number is for period. At the same time, what else it communicates? Do you know? This has n is equal to 1 means 1 orbit. This is n is equal to 2 means it has 2 orbits. N is equal to 3 means it's having 3 orbits. N is equal to 1, 2, 3, 4, 5, 6. What does it mean? Size is clearly increasing because there is every time there is an addition of shell. Now in this case, you don't find addition of shell. Now let me explain with examples. So I am speaking about period. So I am moving from left to right, and I already said that size is decreasing. Let me prove it now. The first one in second period is lithium, whose atomic number is 3. Electronic configuration is 1s2 and 2s1. So the starting is, and I told you, remember in the previous class also, number of times I told you n is equal to 1 means k shell, 2 means it is L shell, 3 means it is M shell. So L shell it is now L shell. So yes, let me represent the same thing. This is n is equal to 1. two electrons, first one. Next it is another shell, new shell, right? And here electron is here, 2s1. This is regarding lithium. Next one, next to lithium, beryllium, it is beryllium. Atomic number is 4. And the configuration is 1s2, 2s2. So there is no increasing in the shell. This electron, this next electron has to go into the same shell. Then from beryllium it is boron, whose atomic number is 5. So it's 1s2, 2s2 and 2p1. Again same, there is no change in the shell. Shell number did not change. Shell or orbit means the same. The next, this extra electron what has now come, it has to enter into the same shell. Next comes what? Carbon, whose atomic number is 6. 1s2, 2s2 and 2p2. Next electron also enters into the same shell. So it goes on. So neon. My last one is neon, isn't it? In second period, last one is neon. So its atomic number is 10. So it's 1s2, 2s2 and 2p6. So it is 2 comma 8. So I have to fill the remaining 8 in this. Actually it is not all of a sudden. All of a sudden neon means I am not filling all the 8. There are elements here, isn't it? Nitrogen, oxygen, then fluorine, then comes neon. So like that, now tell me, how many, when you speak about lithium, how many electrons were there? 3. How many protons were there? 3 protons, because atom is electrically neutral. Same number of electrons and protons. Directly I'll go to neon. Now the number of electrons in neon, 10. Number of protons in neon, 10, because atom is electrically neutral. Now you see the number here, number of electrons are 3, number of protons are 3. So I have gone one by one, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. I reached neon. Neon, the atomic number is 10, therefore 10 electrons, 10 protons. Just imagine, no? Protons are positive charge, electrons are negative charge. How much positive charge has increased from lithium to neon, man? So much it is, right? So much it, 8 number has units have increased. 8 units of proton has increased from when you speak from lithium to neon. Proton pulls electron towards its center. Now electrons are not going far from the nucleus because they are entering into the same orbit. N is equal to 2 orbit. Therefore pull will be more pull, right? Therefore what happens, atomic size decreases in period, because force of attraction is more. So they are pulled, electrons are pulled towards nucleus. Okay. There is one more topic called as shields, screening effect, shielding effect. See, this n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Suppose you are speaking about n is equal to 4 and electron here. So these are called shields, or these are also called as screens. See, this is n is equal to 4. So how many screens are there for this electron? 1, 2, 3 screens are there. This is a hurdle. These 3 are the hurdles. They are what you can obstacles between this electron and then this nucleus. These are obstacles. More number of obstacles, then force of attraction will be less, because electron has gone to a long distance, because atomic size has increased. Why you say atomic size has increased? Because number of screens has increased. Now you compare this with this one. Though the number 3 has become 10, you don't find any shells and extra shell or extra shielding effect here. And the number of protons increased. That is the key point here. Number of protons increased this case. Number of protons. 3 protons have become 10 now. 10. Started from 3 and 10. 8 altogether. 8 addition is taking place. Therefore, it becomes very difficult for what? It becomes difficult for electron to have an extra shell, because it is entering into the same shell. Okay, right. In this way, in period, atomic size is said to be decreasing. Now let us discuss about the same thing in case of groups. In group, as I told you, right, in period, as we move from left to right, same manner, now it is group. So you have to say in group as we move from top to bottom. Now top to bottom, what is happening? See, n is equal to 1, I said no clearly just now. This is nucleus, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. So clear, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. Every time there is additional shell, there is extra shell. So shells, these are called as screens. So extra screens between last electron and the nucleus. This is also called as shielding effect. So more shielding effect more screens, what happens? Size is more. Size is more. Force of attraction is less. Force of attraction is less means because size is more. Right? Now we will see. What is the first element here? Hydrogen. Number 1. 1s1. So it started with K shell. Now lithium. Number 3. 1s2. 2s1. Completely there is an additional of shell. So if hydrogen, if I represent hydrogen like this is hydrogen, hydrogen. Now lithium means I have to take one more shell because complete there is an additional shell. Then come down still sodium whose atomic number is 11. So it's 1s2, 2s2, 2p6. Your 2 is finished. Your 2 is finished. Then it comes 3s1. So you are having extra shell again. Right? Then comes potassium whose atomic number is 19. So it's 1s2, 2s2, 2p6, 3s2, 3p6. See, you finish. You finish all your 3's also. Then comes 4s1. So you're having one more shell. So this is said to be increasing. Size is increasing. In group, size decreases in period. Once again comparison. In period, there were no extra shells. Means screening effect was not increasing. Shielding effect was not increasing. And number of protons increased. Force of attraction increased. So they are pulled. Electrons are pulled towards nucleus. So size decreased. In this case, what pull? What happens to the nucleus? Though there is addition of protons. Yeah. Here one proton. Here 19 protons. When you go down, I am comparing with fourth period, isn't it? So when you go down, so I am in fourth period. I mean to say I am in fourth period, but I am speaking about group only. I am speaking about group only. I am in fourth period. That's all. So what happens in the group? I have come to potassium. From year to year, 1 has become 19. 18 extra protons have come. But still what happened? Size has increased a lot because every time there is addition of shell. Addition of shell means force of attraction is less. Therefore, atomic size is said to be increasing. Now, next topic is about ionization energy. Second topic is about ionization energy. In short, it is called as IE. There's one more name for this. It is also called as ionization potential because don't get confused. Sometimes in exam they are asked by second name. Now you see, listen to the definition. It is the minimum energy required to remove an electron from the outermost orbit. See, what is he saying? The minimum energy required to remove an electron from the outermost orbit means to remove an electron from the outermost orbit. If you want to remove an electron from the outermost orbit, you require some energy. First thing, catch that point. To remove electron from the outermost orbit, you require some energy. See, for example, I want to place this plant down. I require some energy. So in the same manner, to pull out electron from the outermost orbit, you require some energy. And that energy is called ionization energy. Now what happens in period as we move from left to right, size is decreasing. When size decreases, okay, when size is decreasing, what happens to force of attraction increases. Plenty of force of attraction from proton to electron. Electron is pulled towards proton and you want to remove that electron from the atom. What happens? Tell me. It becomes difficult for you. You require more energy. Why? There's a more force of attraction. Now electron is pulled towards nucleus or proton is pulling that electron towards itself. Therefore, you want to remove this electron means you require more energy. Now in group, what happened? Tell me. Size is increasing. Size increased like anything, okay? And then to remove the last electron from the valency shell, you require very less energy because the force of attraction is less. I will show you, right? Now let us see how ionization energy increases in the period. So the first element, second period is what? Lithium. Number 3. 1s2. So here is the nucleus, first shell, 2 electrons. Next it is 2s1. So it's here second electron. Okay. Next lithium, next beryllium. Atomic number is how much? 4. 1s2. Already 1s2 I took. 2s1 is finished. So it's 2s2. So one more electron. Now what happens? As I told you, already I told you, in case of atomic size, number of protons increased here. So nuclear charge increased. Nucleus is positive charge. dominated. Okay, so it is pulling the electron towards its center, because electron is at the same equidistance as it was for the 2s1. Now what happens, force of attraction is more, so little bit of size will shrink, right? So you require more energy to pull out this electron, right? That is what it means. Now we'll speak about group over here. Group, what it is told, in group, as we move from top to bottom, atomic size increases. Atomic size will increase in group. So see, it's like this. First one is hydrogen, whose atomic number is 1. So it's 1s1. So let me represent, this is 1s1, first shell, K shell, 1. Now next one down, lithium it is. I am moving in group, okay? Lithium, atomic number is 3. So 1s2. So I need to fill one more electron for this. Then it is 2s1. So I should take an extra shell. It's here. Lithium. Then comes sodium. Now atomic number of sodium is what? 11. And the configuration is 1s2, 2s2, 2p6. See, 2 is over. Completely 2 is finished. 2 started here. There was no 2 when hydrogen, we wrote hydrogen. Lithium, in lithium 2 started. Now in sodium 3 starts, 3, third one. So every time size is increasing. So force of attraction will decrease. So you require less amount of energy to pull out the electron in case of groups. So one thing you can remember, simply, easy way, atomic size is always inversely proportional to ionization energy. So you can remember the atomic size is inversely proportional to ionization energy. Because if the atomic size decreases in the period, ionization energy increased to pull out the electrons. When the atomic size increased in the group, ionization energy required is decreased to pull the electrons, because it don't require more in case of group, because size is increasing, it is easy to pull out electron from the outermost orbit. This is all about ionization energy. Then the third one is electronegativity. It is represented with En. It is a tendency of an atom to attract bonded pair of electrons. So atom has a tendency of acquiring electrons to obtain stability. This already I explained you in the previous videos, right? Among all these 118 elements, except these 6, all others are unstable. They don't have required 2 or 8 electrons to obtain stability. They require 2 or 8, isn't it? They don't have this 2 or 8 in their outermost shell, except these 6 inert gases. Now, so what happens, electronegativity, it is a tendency of an atom to attract bonded pair of electrons. Who you think will have more tendency to acquire electrons? Elements which are here, 7, 8, 9, okay, nitrogen, oxygen and fluorine, they have more tendency of acquiring electron. So automatically now I gave you a clue. I said that these electrons which are like nitrogen, oxygen, fluorine, they have more tendency of attracting electron, because when you speak about nitrogen, its number is 7. So it is 2 comma 5. So it requires how many to become 8? 3. Like in the same manner, now oxygen, if you take, its number is 8. So it is 2 comma 6. So it requires how many? 2, right? Now next one is what? Now fluorine, its atomic number is 9. That is 2 comma 7. How many does it require? 1. Okay, it requires 1. So in this way, if you discuss, then the electronegativity of nitrogen is 3.04. Electronegativity of oxygen is 3.44, and electronegativity of fluorine is 3.98. Now I'll write down in this manner: nitrogen, oxygen, fluorine. The electronegativity of nitrogen is how much? 3.04. The electronegativity, all these are electronegativities, okay, values. The electronegativity of oxygen is how much? 3.44, and the electronegativity of fluorine is how much? 3.98. So nitrogen acquires how many electrons? 3. Oxygen acquires how many electrons? 2. And fluorine acquires how many electrons? 1. What do you understand? The one which is acquiring 1 electron is having more electronegativity. The one which is acquiring more number of electrons, it is having less electronegativity. But still, What is happening in the period? Electronegativity is increasing. Electronegativity, as you go move from in period from left to right, it is increasing, right? Okay, so electronegativity is increasing because just now I told you, no, what is that? It is a tendency of an atom to acquire bonded pair of electrons. I'll give you one more idea so that it will be much more easier for you to remember this property. Electronegativity is more for small atoms. Remember, electronegativity is more for small atoms. Right? Now, what did I mean? Electronegativity is more for small atoms. More for small atoms. What do I mean? Where do you find small atoms? In the period. Yes, small atoms you will find in the period only. Why? Because just now you said no. In period, as we move from left to right, atomic size decreases. So as you move on, what happens to your atomic size? Huh? Decreases. This is what happening with atomic size. So if this is the size of lithium, right? Lithium, my favorite second period, lithium. Then what will be the size of fluorine? This will be the size of fluorine. And what is told here, electronegativity is more for small atoms. So electronegativity of fluorine, this is lithium, as I said, fluorine is more, isn't it? How much did I tell you just now? And 3.98, right? And then if we speak about nitrogen and oxygen, just now I said oxygen is 3.44. So it is very clear, atomic size is decreasing, so electronegativity is increasing. Right? Now in group, just opposite to this one is a group. In group, as we move from top to bottom, atomic size is increasing. If atomic size increases, then automatically electronegativity decreases. Little bit you can discuss, okay? Lithium's electronegativity is 1. Electronegativity of lithium is 1. Come down, the electronegativity of sodium is 0.98. Yeah, very clearly what is happening as you go down, electronegativity is decreasing. So now finally, in period, as we move from left to right, electronegativity is increasing. In group, as you move from top to bottom, electronegativity is decreasing. The reason is size. Okay, size. And small atoms will have more electronegativity is a clue for you. Next, coming to electropositivity, just opposite to electronegativity is electropositivity. But I will give you an explanation for this. So same way, just now we have seen electronegativity was increasing, isn't it? So automatically electropositivity will decrease in this case. Just now in the group, what happens to your electronegativity? It was decreasing, isn't it? Now electropositivity will increase. Now what do you mean? See, by losing electron, atom will gain positive charge. By losing an electron, atom will gain positive charge. In this case, where is the possibility of losing electron? All these are ready to accept electron. Nitrogen is ready to accept 3. Oxygen is ready to accept 2. Fluorine is ready to accept 1. But in this case, when you speak about, they are ready to leave electrons. Now, to lose an electron, size should be more. Yes, quite natural. Size should be more. So that what is happening in the valency shell, nucleus will not come to know, because size is more. Now in this case, size is less. You remember atomic size. So for everything, the key point is atomic size. One thing you remember, for everything, the key point is atomic size. In period, atomic size decreases. That much if you remember, it's over. Why? Because if size is decreasing, ionization energy required will be more. So that was our topic clearly. Next, small atoms will have more electronegativity. Clear, electronegativity also increased in period. Now I am speaking about electropositivity. Positive. How will an atom gain positive charge? By losing electron. How can these lose electrons? Their size is less. Size is less. Force of attraction is plenty. So it is not easy for them to lose electron on their own. But now when you speak about group, what happens? Tell me, size is increasing. So what is happening in the outermost shell, even nucleus will also not know. Simply I am telling, that's a way to understand. Because the size is more, Valency shell is somewhere, valency shell is somewhere. So what is happening in that valency shell, electron will not, nucleus will not come to know. You can understand in that way. Size increases, force of attraction decreases. So simply, easily electrons may be removed from the outermost shell. The moment you remove an electron, then it becomes positive. Remember, ion, right? They become ions. As I told you, sodium atomic number is 11. Electrons will be 11, protons will be 11. If you remove one electron, automatically positive domination increases. Protons will always remain 11 only, but you removed electron. Electrons have become 10. Electrons have become 10, protons are 11. So automatically positive charge domination is there. Such an easy thing, easily, how did it lose electron? Because size is more. So what is happening at that corner? Not known by the nucleus. Okay, right, very good. In that way, they gain positive charge. Now coming to metallic characteristics. Our fifth one is metallic characteristic. In the periodic table, do you know most of them are metals? All these are metals. So you find metals this side in the periodic table. Once again, one more rough. I'll draw a rough periodic table for you. This is what the periodic table is. This side you find metals. Most of them up to here, almost up to here. These are all metals only in the periodic table. And you will find non-metals here. And in between there is a demarcation line. This is called demarcation line. It's like steps. Okay? It goes on like that. So the element which are on either side of this demarcation line, they are called metalloids. They have the both characteristics, metal as well as non-metal characteristics. So metals you find this side. You find metals this side, right? When you go that side, will you find any metal that side? No, no. So in period, as we move from left to right, automatically your metallic characteristic, what happens? Decreases, because you don't find metals on the other side, that side, right side. So in the same manner, when we move top to bottom, what happens? Metallic characteristic increases. Okay. Then comes your sixth topic, and moreover, metals are ready to lose electrons. They are all cations. They are all cations. And non-metals are ready to acquire electrons. They are all anions. Anions is negative. Cation means positive. That is another way of explanation. Now my topic is what? Non-metals. Where do you find non-metals? You find non-metals on the right side. So if you move towards them, automatically the property, the value starts increasing, and opposite to that one decreases. Right? That's what it is about metallic and non-metallic characteristic. In the periodic table, most of them, these are metals and they are non-metals. If you speak about metal and move from left to right, you won't find metals there. Therefore, it is decreasing property. Right? And non-metals, when you speak about, your non-metals are found that side only. And in case of non-metals, if you move from left to right, you will find them there. Therefore, it is increasing. Right? Non-metals are all anions. They acquire electron and get negative charge, while metals are ready to lose electron. They are positively charged particles. Okay, right. Then last and final one is valency. You should know valency. Valency of first A group is 1, valency of second A group is 2, valency of third A is plus 3, 4, valency of 4 is plus or minus 4. Now here valency of fifth is minus 3, sixth is minus 2, minus 2, and 7th is minus 1, 8th is 0. So in period, as we move from left to right, okay, regarding this is about 7th property and valency. So in period, as we move from left to right, valency does not follow regular trend, doesn't follow a regular trend, doesn't follow a regular trend. Why? See, starting is plus 1, plus 2, plus 3, plus or minus 4, then it becomes minus 3, minus 2, minus 1, 0. So it does not follow regular trend. Now in group, when you speak about, very interesting in group actually, does not follow regular trend in period. In group, it remains same. I told you, no, if you are speaking about group or period, you should remain in the same group or period. So I am inside first A. So valency for hydrogen is 1, plus 1, lithium it is plus 1, sodium plus 1, potassium plus 1, rubidium, cesium. So it remains same, beryllium plus 2, magnesium plus 2, calcium plus 2, strontium plus 2, like that. So it remains same. So in group you have to say it remains same. So in this lesson you have got information skill questions, reflection on concept questions. So the next video will be on reflection on concept and application on concept.